Hi Year 10 Science. In this video, I will show you how to draw a line graph, which is very important for your assessment task coming up this term. Now, please go ahead and access this worksheet on Google Classroom and read the scenario, because in this video, we're going to go straight into filling in the table of results, which I've already done for you, and doing the graph. Now keep in mind, girls, when you fill in a table of results, this side of the table, which is the left side, will show your independent variable. So the variable that is changed. And the scenario in this worksheet states that the variable that is changed is the volume of water given to each plant. So the volume is changed from 0 mils, 5 mils, 10 mils, and 20 mils. Now at the top of your table, you are labeling it with the dependent variable. And this is the variable that is measured. Now the variable that is measured in this experiment is the height of the plant, and you must always put your units to indicate what unit you're measuring in. And then of course you've got trial 1, trial 2, trial 3, so the experiment was repeated 3 times, and you calculate an average. Now make sure, I just want to double check, when you calculate the average, let's do it for the first one, you do a calculation of 0 plus 5 plus 2 equals, and make sure you press equals before you do any division. So 0 plus 5 plus 2 equals a value, and you divide that value by 3 and you get 2.3. Now keep in mind, for this average here, in your calculator it will say something like 2.66666. We round it up because 6 is larger than 5, so we round it up to 2.7. All right, so let's get straight into the graph side of things, and I'll zoom into that. So first of all, a graph needs a title, and the title must show what the graph is showing. So you have to have an appropriate title. And for me, I'll probably write in this title, the height of plants which receive different So the height of plants which receive different volumes of water, because that's what the graph is showing. Now on the x-axis of your graph, you will always plot your independent variable. Now what is this independent variable? Up top here, it's the volume of water. For your experiment, for your assessment task, your independent variable will be different, but make sure you have your independent variable on the x-axis. All right, so for this example, it's volume of water that is given to each plant. As you can see, there's a bracket here, and that's because labeling the axes of a graph must always include units, and the units for volume are milliliters in our case. Now the y-axis also has to be labeled, y-axis. And the y-axis is labeled with the dependent variable. And the dependent variable in this investigation, if I can show you again, is the height of the plant. So we go ahead and write height of plant. And again, the brackets, because you have to write in the units, and they're measured in millimeters. Once you've labeled the axes of your graph, you will now figure out a numerical scale which goes along the x-axis. Now, a numerical scale means that you're going to have to figure out which numbers to put on your x-axis that are evenly spaced on the graph. Now, volume of water, we have to plot these values here, 0, 5, 10, and 20. So what could we possibly put on the x-axis that will fit this data? I can go ahead and say, okay, I know what it is. It's 0, 5. So this space here is 5, a scale of 5. So the next one should be 10, then the next one should be 15, and the next one should be 20. and that fits the data up top. However, I have not used the majority of the space of this graph paper, and I need to learn that I need to use a lot of this space so that my graph is clear. So I'm not going to do that. What I'm going to do is every 3 spaces, I'm going to have an even scale that every 3 spaces equals to 5 mils. So 1, 2, 3, 1, 2, 3, that's 10. 1, 2, 3, that's 15. 1, 2, 3, and that's 20. To help you, mark them down so you can see that clearly. All right, now we're going to do an even scale for the y-axis. And on the y-axis, we have height of plant. Now we only plot the average height of plants. So you don't do the trials, don't worry about the trials. You need to plot the averages. Having a look at the averages, the largest value is 2.3 millimeters. Sorry, the smallest value is 2.3 millimeters and the largest value is 20. If I have a look at my y-axis, what scale could I use to include all of these values? If I go up by 1, will that work? So starting with 1 here, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It fits up to 11, but our largest value is 20, so that's not going to work. What other scale can we use? All right, so let's do 2, 4, 6, 8, 10. Is this going to work this time? Are they evenly spaced? 2, 4, 6, 8, 10. So 1 square equals a value of 2 millimeters. 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. Okay, so that is a very even scale, an even space of 2. Now we're ready to plot. Again, remember, you only plot the average values. So let's start with our 0 mils. So when the water is 0 mils, when the plant received no water or 0 mils of water, the average height of the plant is 2.3 millimeters. So if we go to 0, we find the point 0, and we find 2.3 on this scale. Now this is 2. In the middle is 3. Isn't that right? Because in the middle of 2 and 4 is 3. And obviously 2.3 will be around here. Now go ahead and put an X. I don't want to see massive dots on your paper. I want to see X's. Then for 5 mils of water, we have an average value of 14. So let's go find 14. There it is, 14. For 10, we have an average value of 20. And for 20 milliliters, which is a lot of water, we have a height of 2.7. So again, using the same scale, 3 is here. So 2.7 will be just under it. Now, if you have a look at this data, we can clearly say that the plant was the tallest or had the greatest height when it received a volume of 10 mils of water every single day. Now, for this data, you will have to draw a line of best fit. Now, a line of best fit shows where the data is going. In this example, it's quite difficult to draw a line of best fit, but basically a line of best fit is a line that is an equal distance away from all of the points. And if I were to do that, I'll probably do it like this. And that means that this point is an equal distance from the line compared to this point. And this point 2 is an equal distance from this line. I hope that helps you do your graphs, Year 10. Please let me know if you need any help in Google Classroom in the comment section.